Hello and welcome to the webinar on the Logic Helper driver. My name is Vincent Bova, Director of Dealer Experience on RTI, and I am going to give you a quick introduction of why we use the Logic Helper driver. As powerful as RTI is, we only really have the ability to evaluate one system variable at a time or one flag at a time. For example, if you have a cable box and you want to evaluate the power flag of the cable box, or a system variable where you're evaluating two-way data, such as the power of the Yamaha receiver or a Denon receiver, you can only evaluate one status at a time. What the Logic Helper driver does is it allows you to evaluate more than one either flag or even more than one system variable, which is a two-way status. All right, so how does this work? How do I show you how this works effectively? Well, I had to give you an example of, a crude example, but an example of what we're evaluating here. In this system file, I just created 4 rooms. I put a cable box in each room, and I made sure that the cable box didn't have a discrete on and off. It just had a power toggle. And then I made buttons on the home screen of my global controller that just basically power toggle each cable box and then toggle a flag from set to cleared or cleared to set when the box is selected. So with this variable, I could turn on each of these boxes and invert a flag status, which will toggle the flag state from true or false. Also, I created variables on each button to reverse state the button if the flag is actually set. So the way this will work is when I press this button, it will reverse state the button if the flag is on, meaning the cable box is on, and it will go back to its normal state when the cable box is off. Okay, so I can obviously evaluate each one of these devices. For example, if I wanted to evaluate what a flag was, I could just simply go into the if flag statement and I could say if the living room cable is on, and I could decide what it does. The problem is I really can't evaluate in this single statement more than one flag at a time. How do you evaluate more than one flag at a time? Well, one way to do that is through the Logic Helper driver. Let's take a look at the Logic Helper driver. Once you load the Logic Helper driver onto your system and you go to your driver properties, here's what it's going to look like. So what it will do is allow you to evaluate 32 items that contain different flags or system variables. So for example, what if I wanted to know and evaluate all 4 of those cable box power? Maybe I want to know if any of them are on, or if none of them are on, or if all of them are on. That's what the power of the Logic Helper driver lets us do. So first, let's start by creating a Boolean value, which we're going to evaluate. Let's call this cable power status. And this is basically going to evaluate all of our cable box power. And again, it's going to use different methods of finding out if any of the cable boxes are on or if none of them are on. And it's going to create this cable power status. It's either going to be true or false based on these different values. So let's see how this works. I created my Boolean name, and now let's pick the variables that I want to evaluate. In this case, I'm going to evaluate flags. So I'm going to go to my flags, and I'm going to put in flag 1, the living room cable box. But then I also want to evaluate the second cable box. So let's do the bedroom cable box 2. And let's also add the den cable, and we'll add the bedroom cable as well. So this cable power status is basically a flag, and we can evaluate all these different flags within this value to see if any of them are true, if any of them are not true, if all of them are true, and so on. I'm going to explain the different values soon. All right, so let's go look at our home screen now. So how do I get this to work? Maybe I want to find out if some of these flags are set. Like, in other words, is my living room cable box on, or is any of my cable boxes on? Or all of them are on, or all of them are off? There's 4 different values that we can track with the logic helper driver based on a subset of variables. Let's take a look at the logic we could set up. There is AND, OR, NAND, and NOR operators. Let's explain each one and how it works. Based on that Boolean flag cable status power I set up, that using the AND statement, that cable power status flag will be true when all the cable box power flags are set. Otherwise, it will be false. So let's see how that will work. Cable power status will be true using the AND statement if the variable is true when all of these variables are true. So flag 1 is true, flag 2 is true, flag 3 is true, and flag 4 is true. Then using the AND statement, that cable box, if all 4 of these are set, using the AND value, the power state will be true for the overall flag. If we're using the OR statement, that cable box power status flag would be true if any or all of these cable boxes are set. So even if one is set or if all are set, that flag would now be true if we were using the OR operator. There's also a couple of more operators that are the inverse of these. Let's look at the NAND operator. The NAND operator will be false if all cable boxes are true or set. So in other words, if all 4 cable boxes are on, the NAND operator will set that cable status flag to false. And if any of these are off, this will be true. The NOR operator will set that flag to true if all cable box power flags are cleared or off. So that's weird. That NOR will basically be true if all the cable boxes are off. Otherwise, it'll be false. So again, going back to the logic helper driver, we're evaluating this Boolean, the name here, the cable box power statement, and we're basing these 4 flags on our NAND, NOR, AND, and OR test. Okay, so let's see how this works. Another thing I did was here I created a variable here, a text variable, that basically says AND. So when AND is true, it will say true, and then when AND is false, it will say false. When is AND true? If all the cable box status flags are true. Okay, and so on and so forth. And then that will also reverse state if AND is true, meaning all the cable boxes are on. So let's see how this works. Let's go load the system file up. I created a virtual panel. We're going to load this up. And we're going to create a virtual panel, and we'll call this logic. And let's run our virtual panel. All right, so you'll see that the flags will automatically, have a value based on what's going on over here. Now let's look at the first one, the AND statement. This says when AND is true, when all the flags we're evaluating in that subset are set. Otherwise, it's false. So we know that and notice that it's false right now. Why is it false? Because in order for this to be true, all the cable boxes have to be set. So let's make that true. Let's turn on cable box 1. We see that it's still false. Remember, all the cable boxes have to be on for the AND statement to be true. We'll turn on that one, we'll turn on this one, and we'll turn on this one. And now we'll see that that lights up to true. Now let's go down to the OR now. The OR stipulates that that cable power status is true using the OR operator if any or all cable boxes are set. So as we uncheck the cable boxes, that flag statement is true until none of the cable boxes is on, and now it will go to false. The none condition is false if all the cable box power flags are set. So we can see here that this is true because none of the cable boxes is set. How do we make this false? If all the cable boxes are on. Then the NAND statement becomes false. Otherwise, if any of them are off, it becomes true. The NOR statement, which is currently false, is true only when all the cable box power flags are cleared. Otherwise, it's false, which it is now. So we know that the only time the NOR operator is going to make sense here is when all of our cable box flags are off, and that will make the NOR statement true. Okay? Now, we could use these in our programming. We could use these operators in our programming. For example, if I wanted to program something here, I can create a macro here that basically uses the system variable test, and I could evaluate the logic helper driver. So I could say, hey, if the cable box end statement is true, meaning all of them are on, do this. Or if the cable box OR statement is true, meaning it's true if any or all of the cable box flags are on or true. Or I could use the NAND, which means this is true only when the variable status is false when all the other variables are true, meaning the cable box is on. Or the NOR, which says the variable status is true if all the variables are false, meaning the cable box are all off. So we could see that there's different reasons that you could do this. If we wanted to set up another evaluator, notice I have a Denon receiver and a Sony driver. These are both drivers. So with the logic helper driver, I could go and create another statement here. Maybe I could say living room devices. And now instead of evaluating flags, I could evaluate the Denon receiver's main zone power, and I could also evaluate the Sony Bravia power variable, the on statement. And I could evaluate if any of them are true, or if both of them are true, or if both of them are false, or if any of them are false. And that's how you use the logic helper driver for evaluating more than one variable. Of course, if anyone has any questions, I will provide this file that I'm using with this webinar, and you'll be able to use this and practice it and see if you can use it for your applications where you want to evaluate multiple flags or a combination of flags and variables to make your programming more powerful. Okay, once again, my name is Vincent Bova, Director of Dealer Experience. Thanks for watching.